We have seen that pi radians is equal to 180 degrees, and we've also seen that we can convert from radians to degrees using these little equations here. So let's go through some examples of these. Now if we started off with what we have here, we can say that the pi radians, so we could say 180 degrees is equal to pi radians. That's just a statement of what we have above here. So that means that if we were to look at, say for example, 90 degrees, then we would have 90 upon 180 times pi. So that would equal pi by 2 radians. And if we were to look at, say, 45 degrees, then we would have 45 upon the 180 times pi. So that would be pi by 4 radians. But what if we had something strange, like say randomly say 127 upon 180. So it was 127 degrees and we wanted it in radians. So it would be 127 upon 180 times pi. So that's going to equal, well, just get your calculator out and check that. So 127 divided by 180 is equal to 0.705. So we could say that that there is 0.705 pi radians. So in order to go from the degrees to radians, we multiply by the pi and divide by 180. So that's just what we've got up here. We multiply by pi, divide by 180, will give us our degrees to radians. Now we don't necessarily need to write these out as factors of pi, so we don't need it to have 0.705 times pi. We could simply write that as, we'll get your calculator out and do 0.705 times pi. 0.705 times pi, and that's equal to 2.2, so that's 2.2 radians. Okay, so we can just write it out in straight radians. We don't need to have this factor of pi. And the same over here, we could put this straight into radians, and the same with all of these. But in general, whenever you're dealing with a lot of mathematics, that in some instances we tend to come up with these factors of 90 degrees, 45, say 30 and 60 and so on and so forth, and it's simpler to write them in terms of just factors of pi, so pi by 2 and pi by 4. So it just simplifies some of the mathematics, but it's not always like that. Sometimes you're going to get just random numbers, say for example here the 0.705 pi, and these would just be written as actually in radians. We wouldn't have the pi in it, we would just write it as 2.2. So let's go ahead and we'll have a look and we'll see what we do whenever we're going from radians to degrees. So again, we can start off with the pi radians is equal to 180 degrees. So if we were to look at, say, pi up in 2 radians, so we'll follow this routine here. So if we had pi upon 2 radians, in order to put that back into degrees, we've got to multiply by the 180 and divide by the pi. So the pi's cancel and you're left with 180 over 2, which is equal to 90 degrees. Now if you the pi by 4, and again you would multiply by the 180 and divide by the pi's cancel, you get 180 over 4, which is 45 degrees. Now again, if you had this strange one here, 127, 0.705 pi, so 0.705 pi radians in degrees, we multiply by 180 and we divide by the pi. So the pi's cancel and you get 0.705 times the 180, which gives us our angle of 127 degrees. Of course, it might not necessarily be written as 0.705 pi. We could just have, say, 2.2 radians. So again, 2.2 radians, well, 2.2 is just the same as 0.705 times the pi. So it's still just the same as saying 2.2, and we would multiply by 180 and divide by a factor of pi. And that's going to give us our angle, which is 127 degrees. So these are quite straightforward, and everything really stems from this little equation here. Pi radians is equal to 180 degrees. So as long as you know this, then you know how to convert from radians to degrees or degrees to radians. Now we've also seen that the great strength of putting your units in radians is that it allows you to equate the length with angle directly. So let's say, for example, we had a pendulum. So there's a pendulum there, and we have a little bob at the end of it. So this pendulum just swings back and forward. So let's say that we let the pendulum swing to a different position. So let's say it swung down to, say, this position here. And then we said that this angle here, now the angle is going to be in radians. So let's say the angle is 0.1 radian. And we're interested in the arc length, that is the length of this arc here that the pendulum bob has moved in. So let's say the length of this here, which is r, is, say, 10 centimeters. And we're asked, what is this arc length here? Well, we can work that out really simply because we know this angle is in radians, and we can say that the length of the arc here is simply going to be 0.1 times the 10, which is equal to 1 centimeter. So that's the strength of using radians, that we can just simply multiply the angle with the length and it'll give us this distance here. So let's say it wasn't written in radians. Let's say we actually wrote this in degrees. Now we know how to change this 0.1 from radians into degrees. So if we took the 0.1, and in order to change it back into the degrees, we've seen here that we can use the equation here above. Okay, so what we need to do is multiply it by 180 and divide by the pi. So if I was to take this and I multiplied it by 180 and divide it by a pi, we'll get that actual angle in degrees. So let's go ahead and get your calculator out and give that a go. 0.1 times 180, and it's divided by pi. That equals 5.7 degrees. So let's say the original question that we gave you was the angle there is 5.7 degrees. So that's now 5.7. And we said the angle is 5.7 degrees, the radius is r, and we're asking for that arc length. Then what we would have to do is we'd have to, in effect, convert the 5.7 into radians. So to get the right answer, it would be 5.7, and this time to go from degrees to radians, we'd multiply by pi, we would divide by 180, so that would be it in radians, and then finally we'd have to multiply by the length r, which is 10. And whenever you multiply all this out, you're going to get a value of 1, so it would be 1 centimeter. But you can see here the beauty of working with radians. We don't need to bother with this pi upon 180. We don't need this conversion factor. We can just simply multiply the angle in radians directly with the length in centimetres and we get our answer. So it's much simpler to do this than it is to do that. Also, whenever we go on and we start looking at calculus, that's differentiation and integration, it works under the assumption that you're actually working in radians, but we'll get on to that whenever we start looking at that in a later section. So thank you for listening. I'll get you on the next video. Goodbye.